Alright, so let's do the question number 60. So this one right here happened to be quite difficult one, but it's okay. Let's just try to figure out what's going on here. So by just reading these problems, I get this SN4 plus somehow react with NO to form NO3 minus plus SN2 plus. Either that or it's going the other way around, right? So, but this is definitely not balanced. So let's just try to do it in a right way. What I meant by the right way is that the electrochemistry balancing is a little bit different from the regular one. So the first step is to separate into two half reactions. One of the reaction looks like this. The only reason that's obvious, right? Because SN4 become SN2 plus, so you need 2 electrons. That's pretty much it. So that's the easy one. And then there is another one, that's NO is becoming NO3 plus. To do this, I think this one right here is explained in the PowerPoint. So balance out all kinds of atoms other than the hydrogen and oxygen. So for this particular case it's N is balanced, right? Then to balance the oxygen, the next step is to balance the oxygen. You have to add the required H2O. So if I add 2 H2O, that add 2 oxygen on the left hand side, now the oxygen is balanced, right? So oxygen is balanced. Now the next step is to balance the hydrogen. I have 4 hydrogen on the left, so I'm going to add 4 hydrogen H plus on the right hand side. Now the left hand side right here, so all the atoms are now balanced, but the left hand side have a 0 charge, right hand side have a 7 plus charge. Is that right? Not 7, 5 plus charge, sorry, right? So I am going to add 5 electrons on this side. Right, 1, 2, 3, 4, 5, right? So yeah. So these are the two chemical reactions that's involved. Now we're gonna balance this one. So how do you actually balance the whole thing? Is to multiply by 5 on this one. Oh, wait a minute. I'm sorry. What am I doing? I'm glad that I actually caught my mistake before I went too far. This is negative. So for that, I am going to have 3 electrons right here. Good thing that I call it early. Good. So this is good, right? NO3 minus, right? So we're gonna balance the electrons because we're gonna add these things and then cancel out the electrons. So multiply by 3 on this one, multiply by 2 on this one. Then what we have is a 3 SN4 plus 6 electron plus 2 NO plus 4 H2O. That's all the stuff on the left hand side. And then the right hand side, 3SN2 plus 2NO3 minus plus 8H plus, and that's pretty much it. So everything is balanced right here. Okay, then we're supposed to calculate the E cell for this reaction, right? Now E cell right here is always potential of cathode minus anode. Let me check, double check the stuff. Yeah, E cathode minus E anode. E cathode minus E anode, right? Then anode is the place that produce electron, right? Which one of these actually produce electrons? That electron magically pop up in the product, which is this one, right? So this is anode, the second one is anode, the first one is the cathode. Now we're gonna have to get the values for these guys. So from the table is I think it's this one. There's SN4 plus becoming that's 0.15. We don't really change we don't really care about the direction of which way it is going. We just get the value directly from the table, even though that the action may go the other way around. You don't change these values. Now anode right here, anode was what was the reaction? Anode was NO and NO3, right? NO and NO3. Where is it? NO3. Oh, right here. It's this one right here. So we just get these values. No matter which direction it is going, it doesn't matter. We just get it, like 0.96. So this one right here is 0.96. Alright, then we just plug it into here. E cathode is at 0.15 minus 0.96, which is negative 0.81 volt. So that is the cell potential for this reaction right here. So we balance the reaction and then we get the cell potential.